Hello, I'm James Ingram from AutoControls-dot-org. Welcome to video number 816, which shows some getting started experiments for using the NCE mini panel for automatic train control, starting with blinking the LED and using the reset terminal and working up to running two trains on one track, and also showing point-to-point operation. If you're not real familiar with this mini panel, it's a sort of a programmable controller for model trains, an off-the-shelf list price $49 item made to be used with an NCE DCC system. There's both an instruction manual and a technical reference manual, which I'm going to try to show here, and that pertain to the mini panel, and hopefully I'm not contradicting them with anything I say in this video. If you're not real familiar with DCC, you should still be able to follow this video, as NCE made all the mini panel commands to be pretty much in plain English. Now, part of this video. This video number 816 has 5 parts. That is to say, it's 5 separate videos. The first video is an unnarrated, fast-forwarded by 20 times, overview of videos 2 through 5. The second video you're watching right now is an introduction to the mini panel and also discusses setting the configuration memory, most notably continuous memory versus non-continuous memory, and also enabled inputs versus disabled inputs. Video 3 shows exercises just blinking the LED. There's no train needed. Video 4 shows some simple run the train exercises. And finally, the final video 5 shows some run the train exercises using a reed switch under the track for train detection, which includes running 2 trains on one track and also showing point-to-point operation. Now, if you've not done it before, programming this mini panel is not really difficult, but it's quite likely very different from anything you've done before. You basically insert the jack of what they call a ProCab, which is this device right here. You normally use this for controlling trains. You insert the jack of this ProCab into the what they call the setup port on the mini panel, which I think is right where I've got my thumb, and then you communicate with the mini panel by using these keys on the keypad, and you can review commands and enter commands via that method. And we'll get into more detail as the video progresses. Thanks for watching. If you use the forwarding subdomain MP for mini panel, mp.autocontrols.org, it takes you to this little links page on WordPress.com, links for getting started with the NCE DCC mini panel automatic train control. The first link is to Mark Gurry's NCE mini panel web page, which gives a good written overview of the mini panel. Second, very important and very useful, there is a corrected version of the mini panel technical reference manual edited by Mark Schuster. And this link should take you directly to that, and it's also linked at the bottom of Mark's page, which is this link here. Let's go down a little bit at the bottom of this page. There's links to the NCE pages on the mini panel. For my site, AutoControls.org, this link will take you to a directory containing a PDF copy of the command file used for this video if you ever want to reference any of these commands. And there's also a blank template file. Now let's get back up to paragraph 3 here. There's a gentleman named Arthur Houston who's very knowledgeable about the NCE system, and there's a link here to his playlist, which contains 20 videos. Actually, if you can, I'd recommend viewing all 20 of those videos, but at least, and preferably before you watch this video, his video titled NCE Mini Panel Installation on the Grande Pacific Model Railroad. That gives a good overview of the mini panel. Also, his videos on the cab bus and the mini panel trigger switch in this last one are also good. And we'll take a look at that quickly at his video if we can. Here's what his video page looks like, and this is the let's slide it over a little bit. Here's the what this video should look like: NCE mini panel installation on the GP model railroad, and this is about a 24-minute video he made, which is a good overview of the mini panel. And here's part of the playlist. There's 20 videos in this. He's a very knowledgeable gentleman. Has a what looks like a humongous model railroad that he's installing that he's put this NCE system on. When you take this mini panel out of the package, here's essentially what you get. It has 16 inputs across the front terminal, that is to say, more over here and then more over on this end. I think there's 30 terminals corresponding to the 30 inputs, and then there's a terminal here, the next to the last one for reset, which can be thought of as terminal 31, and then this is a ground, and these 3 terminals over here are grounds also. Now this is the cord that came inside the mini panel package, and as Arthur Houston mentioned, you got to be careful with these cords. That they're, I think he called them straight cords. All the NCE supplied cords will be straight. You don't want to mix these with your landline telephone cords because they look the same, but I think those are what you call crossed or reverse, whatever the proper term is. But they don't. Telephone cords don't work with NCE systems. Just keep them separate. Now back here in the rear, we've got a if we can get the camera up, we got an NCE old Powerhouse Pro command system, command station. That's what's going to power this. So I'm going to take this cord coming from the command station and plug it into the one of the regular jacks. There's 3 jacks on here, and this is the programming jack, and then these 2 are rather regular cab bus jacks, and I could never remember which was which, and then it finally dawned on me the one that's got a single jack is the programming jack, and then the other 2 are your regular cab bus. In other words, you can plug the mini panel in, and you can plug something else in here, typically a Powerhouse Pro, just like you would normally plug something into the cab bus. But we plug this thing in, we should get a single blink of the LED. There's an LED there which will blink. So I think we get a single blink. There it goes. You saw a single blink when I plugged that in. So you know this is sort of alive. I'm going to take it out, put it in the other jack here, same thing. Plugged it in and we got a single blink. So that's basically as far as we can go with this thing until we hook something up to it. Notice this doesn't have any outputs. It doesn't control anything by outputs. All it's got is these 30 inputs here. Yet all it's controlling is done over the control bus, just like a regular cab. You can almost think of this thing as if you picture a robot holding a ProCab, that's what this amounts to. It's kind of like a robotic cab, but it does all its work over the cab bus by sending commands, just like a ProCab would send commands. What we can do next is hook 2 wires up. What I've done here is I put a green wire into the ground terminal, and then that red wire there is going into the reset terminal, which would be terminal 31. And when we normally this would be a push button to force it to reset, but a pair of wires will work also. So if we touch these wires together, we should get a blink out of that LED. You can see if I touch these wires, it's blinking for us. So every time I touch these wires, we get a single blink, and we can keep doing that as much as we want. But that's basically a simple way you can communicate with this thing and feel like you're kind of communicating with it without having to go through a lot of programming yet, or even hooking up a ProCab. As many times as I as many times as I touch this wire, it will blink the LED. And again, what that blink confirms is that the reset command has been executed, or I don't know if it's a command, but it's reset the mini panel. And we have to do this with these automatic controls routines because typically they're at a wait, they continuously run, and typically they're at a wait statement. So you have to basically force the mini panel to reset by having a push button hooked up like this, or you can't get it to stop executing. We brought a ProCab into the picture here. Now what we're going to do is review some commands already in the mini panel, and then reset the mini panel to a default, which will take all those commands out and reset it to just like it came from the factory. That coiled cord you see there, that's coming out of the bottom of the ProCab. So let's plug the ProCab into the setup jack, and we'll see what happens. Now our ProCab is lighted up. Push the enter button. Now there are three main choices. 1, setup, 2, review, and 3, test operation. So we're gonna, normally you probably spend most of your time using the setup part. That's how you enter all the commands. But right now we're gonna go into review. So we push 2 for review, and I've got to hit the enter key to do that. And I need to tell it which input. I'm going to say review input 1. So there's what's in input 1 right now. Select loco, and we can hit the enter key. Every time we hit the enter key, it'll move down 1 step. Again, just to review a little bit, there's 30 inputs here you can use. Actually, there's 31, but 31 is like an automatic power up. It executes those commands when you power up automatically. So I stay away from that. I just use inputs 1 through 30, and each input has 4 steps. So you can, in theory, you can put about 120 commands in this mini panel. And in practice, you can't use that many because you get empty spaces where you have to go to the next input. But anyways, if I push the enter key, it's at input 1, step 1. If I push the enter key, it goes to input 1, step 2. If I push it again, input 1, step 3. Push it again, input 1, step 4. Push it again. Now we're at input 2, step 1. So again, each one of these inputs has 4 steps associated with it, and you can put commands at each of those 4 steps. Or said another way, every input has 4 commands that can go with that input corresponding to the 4 steps. So at any rate, if you keep pushing the enter key, you can step down, walk down through all these commands. Now, this is in the manual, pushing the enter key. What's not in the manual, it's in that corrected manual that Mark Schutzer wrote. It's linked from Mark Gurry's webpage. Rather than doing this, and that's fine, but you can also use your increase and decrease buttons to go up or down. So if I push increase, it keeps going down. Notice it's at input 3, step 1. I'm decreasing, I'm going backward. Let's push the increase button. Input 3, step 1, input 3, step 2, input 3, step 3. Now, if we push the decrease button, these are the speed buttons when you normally operate the train, but if you push the decrease button when this is hooked up for programming, it'll go backwards through the inputs. Now it's input 3, step 2, input 3, step 1, and back to input 2, step 4. And you can also use the scroll wheel to scroll up or down. There's 3, 1, input 3, step 2, input 3, step 3. I can go the other way, input 3, step 3, input 3, step 1. I skipped over 2, but it's there. Now the other thing is, if you use the increase and decrease fast buttons, recall when you run a train, this jumps you up 4 speed steps at a time. Here it jumps you through 4 command steps at a time. So it'll go to the next command. If I push increase fast, it went to input 4, step 1, input 5, step 1. So it's jumping over 4 steps. It's going to the next input, but it's jumping over steps 2, 3, and 4. So you can use this to go up and down and review what's in your commands. But the point being, you can see this thing's basically full of commands right now. There's an end here. Occasionally you'll see an end statement. Let's find some. There they are. These, I didn't put anything in here, so this is the way it comes from the factory with these end statements in here, which is basically a do nothing statement. What we'll do is we'll reset the thing, and all these commands you're seeing, like they're now input 15. I put some stuff in here to test it out. You can see there's a bunch of commands in here at input 15 also. When we reset this thing, we'll wipe all those commands out and it'll be nothing but end statements, which is, again, the way it comes from the factory. Okay, here we are again. We're still in the review mode. Now what we want to do to get out of review mode is go down here in the lower left corner is the program escape key. Arthur Houston in his videos makes a big deal out of this program escape key, as he rightfully should make a big deal, because this is what you got to use to end everything. And it also, when you start entering wrong commands, this typically will back you out of a place you didn't want to go. So if I hit the program escape key, it backs us out of the review mode. Now we're back to the main menu. So now we're going to push the 1 for setup. So we push a 1 for setup. Now we have two choices, setup inputs, which is 1, and the configuration, which is 2. Now you probably spend 99% of your time in this first one setting up inputs, because that's how you put the commands in. We'll show that later. But every once, maybe only once when you first set this thing up when you get it, or maybe very rarely, you'll go in and set the configuration. But we're going to go in there right now. So we're going to push a 2, which will take us into the configuration. And here's the thing for resetting. This thing comes defaulted to a cab address 3. And what we're going to do, and this is all in the instruction manual, and if you set it to 0, that's a method to default. That's a method to reset the mini panel the way it came from the factory with its default settings. So I'm going to enter a 0 here and push enter. Now that should reset everything. Yeah, now let's go review things. I'll push 2 for review. Review, I'll say input 1. Push the enter key. Now we'll use the increase key. Step 1, step 2, step 3. See, everything is nothing but ends. This whole I just zeroed everything out of the whole mini panel. It's reset to its factory defaults. And when you put in a cab address 3, when you put in cab address 0, like we did a minute ago, it doesn't actually set it to 0. It can't be cab address 0, but it sets that to the default also, which is 3. So basically, you can see I'm going to jump down through here using the now we're jumping an input at a time. You can see this thing it's nothing but end statements. So it's like a blank piece of paper at this point. Let's look at these modes for a minute. A minute ago, what we did is we plugged a ProCab into the programming jack to put the mini panel into programming mode as opposed to normal operating mode. When we were in programming mode, we went into the review mode and looked at the commands that were existing in the mini panel. Then we escaped out of review mode, we went into setup mode, and we went into the configuration settings within the setup mode, and we set the address to 0 to return the mini panel to its default settings. Now this doesn't really set the address to 0, but when you put a 0 in the address, it results in default settings of the mini panel when you're done, which is the address is 3, and all your commands become filled with the end statements. Then after we did that, we hit the program escape key to back out of the setup mode, and we went back into the review mode and reviewed those memory locations again, and we saw that everything was filled with end statements. Now what we'll do next, we'll go back into the configuration mode, and there's about 5 variables that the user can change, and we need to change 2 of them to set up our mini panel for these series of experiments. Let's look at these configuration memory settings for a minute. When we go into those, there's basically, I believe, 5 of them that we as users can change, and then I believe the manual says 6 and above are not used. This stuff's pretty much in the manual, what we've got here. Our first memory address 0 is our cab bus address, and we're going to leave this set to the default of 3. And incidentally, I believe it must be address 3 when you use it with a power cab. And as we showed a minute ago, and this is in the manual, if you enter a 0 in here, it'll set the mini panel to its default settings. And again, it doesn't, when you enter a 0, it doesn't change the address to 0, but when you enter that 0 in memory address 0, it returns at the default settings, which means the address ends up being 3, which is the way our mini panel is at the moment. And then these next 2, we can just basically leave those the same. I don't even fully understand these, but we can leave them set at the default. Ones we're interested are memory address 3 and 4. Their default is 0, but we're going to change them to 4. And what that means for memory address 3, it'll be continuous memory 4 and above, as opposed to non-continuous memory. And we'll take a look at that in a minute in more detail. And in memory address 4, we're going to disable inputs 4 and above. And what that means basically is the mini panel won't be polling those inputs when it's in an idle state. Now, people who set these up for probably what the mini panel is most commonly used for, routing turnouts, I'm guessing they probably leave these set at the default, because when they're changing turnouts, they would not probably use continuous memory, and they would probably want all their inputs being polled. But for the automatic control type of stuff, which we're showing in this video, we'll set these to 4. And we probably won't have to come back into this for the rest of the video. This is a depiction of non-continuous memory. And again, this is the default, and is controlled by configuration memory address 3, which is defaulted to 0, giving us non-continuous memory. Now we've got our input starting with input 1, going down to input 5 is shown here, and then continuing on down to input 3. So you've got all these basically 30 inputs to work with, and each input has 4 steps. Now with non-continuous memory, it'll just execute the four steps for each input and not continue any further. For example, if there's a push button connected to input 1, it would execute these 4 commands. Say these were to throw turnouts, like people are using them for throwing turnouts in the layout, it would execute these 4 turnout throwing commands and stop. Now if we had a push button connected to input 2, it would tend to execute these 4 commands just as it did above here. But however, if say we need more commands executed, we have to, in the 4th step, we have to have a link command to get it to go to the next input. In other words, this says link to input 3. So when it comes down here to step 4, it'll jump to input 3. Then it can execute 3 more commands. And then if we need to continue, we have another link to input 4, which will take it down here. 3 more commands, link to input 5, 3 more commands. Now, that's 12 commands. If that's everything we need to do, and we need to repeat this, we can say link to input 2, so it'll go up there and start over again and just keep executing these commands continuously. Again, if this was in a layout, say like Arthur Houston showed it in his video, mounted up under his platform used to control turnout routing, I'm guessing he'd probably have this set for non-continuous memory, and he'd be having series of throwing the turnout commands here and only using a link statement when he needed to throw more than 3 of them at a time. And also keep in mind you can use macro commands in here for the turnouts also. Now let's take a look at the continuous memory next. Here's continuous memory. And again, controlled by configuration memory address 3. And again, we've got the same 5 inputs shown here. But now in this case, you have to put an end statement. Like if we have a push button connected at input 1 and we start executing this command, it'll just want to go continuously. So if we just want to execute these 4 commands, we have to put an end statement in here to stop it. Otherwise, it will just keep going. Now, if we have another push button here at input 2 and we start executing commands, it'll just keep going. You see, we don't need those link statements like we had before because the memory's continuous. And again, down at the bottom, after 12 commands, we have a link to input 2, which takes it up around, and it'll start executing those again. So it'll keep going in a loop. Now, for what we're going to do for this video, we're going to set it to be continuous for inputs 4 and above. So the first 3 inputs will be non-continuous memory. Inputs 4 up through 30 will be continuous memory, and I think that'll work okay for this video. Let's talk about these disabled inputs for a minute, and that's controlled by configuration memory address 3. And again, repeating from earlier, the default for configuration memory address 4. The default for configuration address 4 is 0, which means all inputs enabled. And that's probably how people who use this thing for throwing turnouts leave it set with all inputs being enabled. But we're going to set, for this video, we're going to set configuration address equals 4. And from the previous discussion, configuration address 3, we also set that as 4, which was non-continuous memory. But they're the same in this case, but they don't have to be the same. But what this means with this configuration address 4 being set to 4 is that any inputs 4 and above will be what they call disabled. The mini panel won't poll them. Inputs 1 through 3 will still be polled. So if you hook a push button to input 1, 2, or 3, when the mini panel's in the idle state and it's kind of watching those inputs, if you push input, the button connected to input 1, it'll execute these 4 commands and stop because of the non-continuous memory. If you had a button connected to input 2, it would execute these 4 commands and stop. And likewise, if a button was connected to input 3, it would execute these 4 commands and stop. However, if you hooked a button, say to input 5, 6, or any of the memory locations down to input 30, and you push that button, nothing would happen because it's not looking at those inputs in the idle state, i.e. it's not polling those inputs. Now let's do a few summary statements here. In this example, if inputs 4 and above are disabled, when in the idle state, the mini panel continuously polls inputs 1 through 3. Inputs 4 through 30 are not polled. For example, if a button connected to input 3 is pushed or a read switch is closed, that is to say grounded, the commands for input 3 will be executed. But if a button is connected to input 4, 5, 6 or higher, the mini panel will ignore that button. Now here's the important thing in this purple square here. The disabled inputs 4 through 30 will still be examined, but only at the time they're queried by a command, such as a wait till input 9 is ground or skip if input 16 is open. So like, for example, we don't have input 9, but if we had a read switch connected to terminal 9, and then we had a command that said wait till input 9 is ground, the mini panel at that point in time only would look at input 9 and see whether or not it was grounded, but otherwise it won't be looking at input 9. And this is kind of a subtle point, but when you're operating these things with disabled inputs, the commands are sort of divorced from the physical terminal on the mini panel. In other words, you could have a read switch connected to input 6, but you could query that read switch down at input 29. So these kind of just become, for the most part, memory locations. And one other point to note, it appears to me like if the mini panel is being operated in a test mode, which is part of the program mode, none of the inputs will be pulled. Said another way, what I found was when I was in the test mode, my push buttons didn't work. If I had a push button connected to input 1, it didn't react to it when it was in the test mode. If I took it out of program mode and had the mini panel operating in regular operations mode, then the push buttons inputs would be looked at. Here we are ready to set these two configuration variables we want to change. So let's power up the system. There we see our default screen. We press enter to get to our main menu. Now we want to choose option 1, setup, push the 1 key, and we want to go into configure the configuration, so we'll press the 2 key from this point. Now we see cab address is 3, that's the default, so we're just going to leave it that way by pressing enter. Memory address 1, I'll push enter to see what it is. That's set to 5. Memory data is 5. That's the default. We're going to leave that alone. Memory address 2, I'll push enter again to see what that is. Memory data is 0. We're going to let that alone also. Memory address 3, now that's our continuous memory. That's going to be set to 0, but we want to change it to 4. So I'm going to push a 4 and enter. Memory address 4, that's our disabled inputs. We want to set that to 4 also. So I'm going to push enter to see what it is. And it's the default 0, but we're going to enter a 4 because we want to change it to 4. And we'll push the enter. Then memory address 5, we'll push enter to see what that is. That's 0. Then we go to memory address 6 and above, and according to the instruction manual, it says memory address 6 and above are not used, so we have no interest in changing anything above, really, memory address 5. I should mention memory address 5 is for interrupting wait commands. I've never used this, but it's explained in the technical reference manual. If you want to set up an input to interrupt a wait command, you can do that. Just be aware it's there. If we hit the program escape key, we'll back out of this. Now we can go back. We should be able to go back in and review those and verify they're what we thought they were. So I'm going to press 1. Now the review, we've got a review option, but that's for reviewing inputs, and this is configuration. So we have to go back into the configuration menu. So I'm going to push 1 for setup again and press 2 again for configuration. Cab address 3, memory address 1, enter. That's 5. That's the default. That's what it says it's supposed to default. That's the debounce timer, whatever that is. Memory address 2, push the enter to see it. That's 0. Memory address 3, now that's one we changed. It's set to 4. That's what we want. Memory address 4, that's the second one we changed, and that's set to 4. Memory data is 4, that's what we want. Then memory address 5, push enter to see that, and that's 0. Then down here on the lower left, we push the program escape key to back out of that. So now we should have our configuration memory settings set the way we want them for the rest of this video. Here's the menu navigation chart for the mini panel. This is page 6 of the NCE mini panel technical reference manual. Now there's one thing missing from this, what's in the official manual, and that's the terminate command, which shows up down here number 7 under Other. This is in the corrected version of the mini panel manual that's on Mark Gurry's website, or I should say linked from Mark Gurry's website. Now let's look at what we've been using so far. Here's our three main top-level selections we've been talking about. The review, which we've used, and we've been doing the setup configuration, specifically the memory address. We changed memory addresses 3 and 4 for continuous memory and disabling inputs. Now what we'll be doing next is actually going in and setting up some inputs, and this is where if you actually were using the mini panel, you'd probably be spending 99% of your time putting inputs into the thing. Now we'll look at the commands we're actually going to use in this video. These circles show the commands we're actually going to use: accessory, loco, and under Other we'll use delays, waits, links, no-op, skips, and the terminate command. Now you can sit down and actually, and these will appear in the display of the ProCab when you start entering them, and you can sit down and enter them that way, which is the way I used to do it, but it's kind of tedious and slow. And what I observed by looking at the way my friend Fred Cupp, who showed me how to do this mini panel, he kind of made up what I'm calling a command library, and let's take a look at that here. Here's what I'm calling a command library, and the key thing is the center column marked entry. You've got your commands here and your action of what it does. This is distilled down to what buttons you actually have to push. So and what's in red is what normally changes, like the link statement, link to input 9, and there's the 9 in the red. So if you're going to link to input 8, you just change this number to an 8. And the rest of the numbers, the ones in black, usually stay the same. So you can just use these statements and reuse them and just change the numbers in red, and you enter them using a table like this. That seems like a lot easier way to do it. So we'll work off of this command library, and we'll go over these in more detail when we actually use them. Here we've got the accessories, delays, accessory we use for throwing a turnout. We don't actually have any turnouts in this video, but we'll use the accessory command just to make the LED blink. Delays, end, terminate statements, link statements, no-ops, select loco, and speeds. Skip if the input's ground or open, wait if its input's ground or open. Now down here is the macro commands where you can set one or more turnouts straight or curved with just one command. We won't use those in this video, but it's important to know that they exist and are possible. Back in video 814, which we had the automatic passing sighting showing 3 HO trains running on the same track, I was out of command space in the mini panel, so by using a macro I could save a couple of lines. Rather than having 2 accessory commands, we could put these 2 together in a macro, which is done in the command station, and just call one macro statement, so it saved a little bit of space. What we want to do here is try to show the entry of a command using the menu navigation chart. And we'll use a quarter-second delay quantity, 4 of them, which will amount to a 1-second delay. So we need to come in through our input and set up input selection, down through the other and over to delays, and then select the quarter-second delay, and then tell it to have 4 of them. So here's our startup window on the ProCab, and I'll press enter to get to our top level menu. So we're going to press 1 for setup. This time we're going to press 1 for input. Now it wants to know what input number we're going to work at. So since this is just demo, we're going to get down to input 30, which we won't probably be using in this video. That's our last input available. So I'm going to say put a 30 in here. And I screwed up and put a 39, so I'm going to back out of that with the escape key. We can go in again here and say set up input number, and see if I can get it correct, 3, 0, and hit the enter key. Now it wants to know what step number. It's defaulted to step number 1, so we'll press enter key to accept that. Now it's ready for the input. So it's showing you the first 2 choices that fit in the window. That's accessory, which is here, in macro. Now you can look at the rest of them by using these keys to scroll. You can see it's showing us the next 2, loco and signal, and you can also use the thumb wheel to scroll, I believe. There's 5, that's what we want, other commands. If I keep scrolling, it'll go back to the beginning and start repeating, but get it on 5. So we know we need to enter a 5 next, and that's this 5 right here for other. So we'll push a 5. Now it says, it's showing us the options: delay, wait, and again there's more options under the other, and we can look at those by scrolling through. We have 3 link, 4 CV, 5 no op, 6 skip, and 7 terminate, but we want delays, so we're going to push a 1 for delays. Now we have 2 delays to choose from. We could use either one. I'm going to use the 1/4 second delay here, which is a 2, so we'll hit a 2, and that's our only options. We only have two delays to choose from. If we try to scroll to look at more of them, there's nothing to see. So we'll hit a 2 for 1/4 second delay. Now the number of 1/4 second delays, we want 4 of them, which will be a 1 second delay. So I'm going to push a quantity 4 and hit the enter key. Now we've done that, so it's ready to accept the commands for input 30, step 2, the next step, but that's all we want to do for this demonstration. So we'll hit the program escape key to get out of the input mode. Now we'll go into the review mode and check that. And we're going to say review input 30. Enter. And there's our command. And that was all ends from when we reset the mini panel a few minutes ago. If we look at the next one, step 2, it's end. Step 3 is end, and step 4 is end. But that's how you can enter a command using the chart. Now the easy way is just to use the numbers from that command library. So let's back out here and let's do it the quick way now. I'm going to say set up input. It's a default to input 30, but I'm going to say step 4. That'll be the last step. Now it's ready for the input. So if I just type in a 5, 1, 2, 4 from the command library, there's the 5, the 1, the 2, and the 4. Hit the enter, tell it we're done. Now it's input 31, step 1, we're done. So I'm going to back out of there, go into review just to verify that. Review input 30. Enter. Now there's the first one we did a minute ago. Now the next 2 should be ends because we haven't put anything in step 2, haven't put anything in step 3, but here's that step 4 we did just a second ago. You see it's the same thing, delay a 1/4 second times 4. So from now on we'll work with the command library rather than the menu navigation chart, which will just give us the numbers we need. And it's the same thing. You're doing the same thing, just a different way to get the numbers you need to punch in. But notice how you're communicating this thing. You're typing in numbers. We mentioned earlier the mini panel has 31 inputs, and there's basically 30 of those are usable to us, the first 30. And each of those inputs, starting with input 1, has 4 steps. So you see what you're seeing here right now is inputs 1 down through input 9, and we can keep going down through here until we come to input 30. And each one of those has the 4 steps, and each one of these slots can hold a command. And again, input 31 is there, but we don't generally use that. Those are automatically executed upon startup. You might want to use this if you ever set up some kind of a display that you wanted it to start out automatically when you turn the system on, but we're not using it in this video. So what you're seeing here is a blank template I created where you can write these commands in. The important thing to remember is you can't move commands inside the mini panel. So if you put commands on line 3 and then you need to do something up here that you need to push these commands down to line 4, there's no way you can move them. You basically have to retype them in, starting down here with input 4. So it's not flexible in that respect. But what we have here is this blank file, and you'll see variations of it throughout the video where I put commands in it. And just to keep in mind, this is a word processing file. It's not an executable file or anything like that. You got to type all this thing in command by command, which is what we'll be doing. But it's handy to have this for reference and planning. So this blank file is in that directory on the page mp.autocontrols.org. It's there as a blank file in PDF format and also in .odt format, which is an OpenOffice editable file. OpenOffice is a free word processing package you can download for either Macintosh or Windows. So it's very handy to use that. But you can do this on a piece of scratch paper or a napkin also. But just to mention, this is available for planning, and also just to visualize that there's 30 inputs that you have available to work in. This is basically our playground area, courtesy of Jim Scorse or whoever designed the mini panel. Here's the apparatus that holds the iPhone over top of the instructions, just for reference. I have a adapter that fits on my tripod for holding the iPhone, but I couldn't get that directly over top of the instructions to video that, so I found this clamp on Amazon that you can see you can clamp the phone, and it's got a flexible neck on it so you can get it pretty much out over top of the instructions. And then, because the iPhones don't have a real good microphone, just think about $20 plug-in microphone that enhances the microphone on the iPhone. But that's just for reference how we were able to shoot this video right directly over top of the instructions with the iPhone. If you're trying to watch this video on an iPhone, the display may be a little bit small to see what's in the ProCab display window. However, you can get a Apple Lightning to HDMI connector that will allow you to use this thing to connect your iPhone via cable shown here to any TV that's got an HDMI input, which is most of the newer ones since around 2008, I believe. And you can get these things on Amazon, shown here. Right now the price on this is $39.99, and it has a lightning connector on one end to connect to your iPhone, and this end is HDMI, which connects via an HDMI cable to a TV with an HDMI input. And if you search on Amazon for this number, MD826AM/A, that's the Apple part number. Now, of course, the question would be, is it worth paying $39 to watch a James Ingram video? Possibly not, but you could use this to watch other stuff also.